All right, I wanted to talk a little bit about normal distributions, and we'll sort of relate them back to the standard normal distribution to start, and then discover just a little bit more about how we can tackle these in maybe a little bit easier of a fashion. So here's an example question. A manufacturer knows that their items have a normally distributed length with a mean of 19.3 inches and a standard deviation of 6.1 inches. If one item is chosen at random, what is the probability that it is less than 15.5 inches long? So I'm going to hop over to Excel here, and I'm going to just drop the question here and then do a little bit of drawing. Pictures are really important for these, and I know that we're a little bit resistant to drawing pictures, but it can really help with the understanding. So I'm going to try to do a normal curve here. And what's sort of different about this one compared to the section before is now we know the mean is 19.3. So this is x bar or mu. Probably shouldn't have tried to cross it out there anyway. Okay, my 19 didn't show up very well anyway. Now if I subtract, okay, my 19 showed up just fine. A standard deviation from each side. We kind of get these, and we can come up with some values here. So this would be 19.3 plus 6.1 over here, which what's that? 25.4. And then we'd add another standard deviation, so we can kind of move those along. And you can add those values if you want to or not. Now, what is the probability? No, excuse me. If one item is chosen at random, what is the probability that it's less than 15.5 inches long? So 15.5 is going to be somewhere over here. And we're looking for this area under the curve. Now, we know a couple of things. Our z-score is equal to x minus mu over sigma. And in this case, we have 15.5 minus 19.3 over 6.1. Now I'm going to do that same thing, but actually have Excel do the work to find me a z-score here. So I'm going to have z equals, and I'm going to do some parentheses here, 15.5 minus 19.3 over 6.1. Now this gives me a z-score of this. Now in section 4.1, I could find the area to the left of the z-score, so the probability that x is less than 15.5 is going to be the normal standard distribution of this z-score and true. True gives me that area to the left, and then we usually round this to 4 decimal places. 0.266, and the 6 is followed by a 5, so that's going to go to 7. Now this is going to be a case here where we're going to want to be careful to make sure we have enough decimal places. Sometimes you got to drag this over and get more decimal places just to make sure that our rounding is done correctly. Now, we're learning here in this one, I can find the area of x being less than 15.5 by using a different distribution. If you notice I start typing normal here, I've got a normal distribution and a normal standard distribution. Now I can use a normal distribution and I can just put in a value here. We're interested in 15.5. What's the mean? Well, the mean is 19.3 and the standard deviation is 6.1, and this is true, that area to the left. So now I've got another function, a normal distribution, that I can use in Excel that will give me the same values without having to shift it. So it's related in that I can make a z-score from it, find a value, find the area to the left using a normal standard distribution, or I can also use a normal distribution and I put in the x value I'm interested in, the mean, the standard deviation, and then true gives me the area to the left. So let's try another question here. A manufacturer knows that their items have a normally distributed lifespan with a mean of 12 years and a standard deviation of 3.4 years. If you randomly purchase one item, what is the probability that it will last longer than 13 years? So I'm going to get a snip. I'm going to jump over here to Excel and try this one. So, okay, some important things here. The mean, that's mu, is 12. Standard deviation, that's sigma, 3.4. And then our x value of interest, 13 years. Now, going back to drawing a picture here. Oops, I think I have to get out of the cell, then I can click here. I'll draw a picture. Now, the picture is really nice. The picture doesn't have to be really nice. But 12 here, 13 years, one standard deviation is 3.4. So somewhere around here might be 13. And we're looking for this area here. Now, I could convert it to a z-score, or I can use the distribution. So, let me make my z-score. It's going to be 13 minus 12 over 3.4. And I could click on those cells, but I'm doing this so that when I look at these here and show this, you can sort of see the work. Now the area to the right of it, the probability that x is greater than 13 then, is the area to the right of that z-score, and my function only does the area to the left. So I've got a normal standard distribution, put in this value, and true. I do 1 minus that, because that's how I can work backwards. And got this 0.38433, so that 3 is going to stay. Here's my probability. Now, we have another function here we can use. The x is greater than 13. I'll do this now using the normal distribution function. Again, I'm looking for the area to the right, so I have to use 1 minus. Now I've got a normal distribution, and my mean, or excuse me, my x value, 13. My mean, 12. My standard deviation, 3.4. And then true here, I'll kick out the same value. So what we're doing here is just adding a little bit to the thing, to what we know. We're sort of building on prior knowledge, and then moving forward just some. I'm going to see here if I have time to squeeze one more question in. And I want to get to one. We're loading. Okay. A particular fruit's weights are normally distributed with a mean of 501 grams and a standard deviation of 20 grams. The heaviest 18% of fruits weigh more than how many grams? Give your answer to the nearest gram. So, snagging this, heading over to Excel, start a new one. I've got some stuff here going on. A particular weights, they're normally distributed with a mean. Okay, I've got mu, 501, a standard deviation, sigma, 20. And then we're now interested in, we've got the heaviest 18%. So, let me draw a picture of what we have happening. We're normally distributed. I like to draw the curve first, then add the stuff because it gets wild if I don't. 501. Now 18%. I know 50% is over here, so I'm going to just say this here is 18%. Now I'm looking for a cutoff here, an x score. Now if this is 18%, this is 1 minus 18%, or 0.82, the area to the left. And that's important because I have to use the functions that give me the area to the left. So my x value here, I'm going to use a normal inverse this time. My probability, that to the left, 0.82. my mean, 501, and my standard deviation of 20. And here is an answer. Now I need to round it to the nearest gram, so this would be 519 grams as the final answer there. Anyway, so I hope that makes sense. Sometimes people like to have these have the information from our question here. So sometimes you might see 1 minus 0.18 here, since that's the area to the left, and then 501, and then 20 there, and it will kind of kick out the same answer. So anyway, I hope that's helpful for you. This video ran just a little bit long. Sorry about that. Let me know if you have any questions. Again, I'm here to help and wish you continued success this term. Have a good one.